Alright, so let's use the same concepts and formulas that we learned previously and apply them to some trickier problems. This tells us that it is an arithmetic sequence, progression sequence, whatever, and it says that the third term is 21 and the 11th term is 85. So third and 11th respective with 21 and 85. So that's telling us that basically what I'm going to do is, why am I doing that? For the third term, I'm going to plug in the, that's not what I want to say. What I'm doing is, my third term is 21, and my 11th term is an 85. So to get that 21, I know that my n is 3. So look up here, see I'm writing the 3. But I don't know the a and the d. So what I got to do is say that 21 equals the correct a plus 3, because this is the third term, minus 1 times the correct d. And that 85 equals the correct a, which has to be the same, plus 11 minus 1 times d, the correct d. So I'm going to simplify those, and it gives me a system of equations. So what that gives me is 21 equals, equals a plus 2d, and 85 equals a plus 10d. So I'm going to multiply the top equation by -1. Alright, and that gives me negative 21, a negative a, and a negative 2d. Now I add the equation, so I'm just solving a system of equations that you guys learned in Algebra 1 and in Algebra 2 and in Finite. So that gives us a 64 equals, cancels out, 8d. So 8 equals d, so the common difference is d. And then to go back and find that, I'm going to plug it back in here and get 21 equals a plus 2 times 8, which is 16. Subtract that from both sides. And that gives me 5 for a. So that means that our first 5 terms, because that's what they said to do, was to write the first 5 terms here. So that's going to be, my first term is a 5, the common difference is 8, so 5 plus 8 is 13, plus 8 is 21, plus 8 is 29, plus 8 is 37. And there you go. Piece of cake. Alright, next one is going to be an even cleverer one. Alright, so geometric. It says that the 10th term of a geometric progression, so geometric sequence, we want the 10th term, so we're not doing a sum of terms, we're just finding the 10th one, so we use this, with positive terms, so that means the common ratio is going to be a positive number, not a negative that would flip-flop them back and forth. And the third term is 16, and the 7th term is equal to 1. So what that says is that the third term is 16, and the 7th term is 21. And how do we get those numbers? Well, again, we get those by 16 equals the right starting number times the right common ratio, and since it's the third term, it's going to be r to the 3 minus 1. And similarly, we get 21, no wait, 21? Oh, dare, sorry. The 7th term is just 1. Sorry about that. So 1 equals a times r to the 7 minus 1. So simplifying our little deal here, we have 16 over equals a r squared. Oh, I keep doing that. A r squared, and 1 equals a r to the 6th. Alright, so now how do we actually find the a and the r? It's not the substitution thing because it just gets really pretty cumbersome. So we're going to be actually kind of more clever than that. What I'm going to do is, if this is our first equation and this is our second, I'm going to divide the second equation by the first. Alright, and that's because this has the bigger exponent, so it just makes life a little easier. So 1 is equal to a r to the 6th. So if I divide this side by 16, that's the same as dividing this by, well, 16 is equal to this. So instead of dividing by 16 here, I'm dividing by a r squared. So I'm essentially just dividing these equations, only I put the bottom one on the top because I wanted the one with the bigger exponent on the top. Oops, there we go. So now that simplifies to 1/16, and I get a over a here, so those cancel, and then your exponent rules, I'll do them off to the side. Over here is r to the 6th over r squared is r to the 6 minus 2, which equals r to the 4th. So those Algebra 1 rules coming back at you again. So that equals r to the 4th. Alright, so what to the 4th would give you 1/16? Well, 1/2 to the 4th is equal to 16, 1 over 16. So, or you can just take the 4th root of both, and you're going to get 1/2 equals r. So yay, we found it. Whoops, what was that? So we found r. Now we just need to find the a. So what I'm going to go do is plug this back into the easier one of the two, so the top r there. And I'm going to get kind of all over the place here, sorry about that. 16 equals a times r, which is now 1/2, squared. So that would be 16 equals a times 1/4, multiply both sides by 4, and I get 64 equals a. So my starting number is 64. Now, what did the question actually ask? Find the 10th term? Goodness gracious. Alright, so you have all that. Copy it down because I'm just about to erase it. I know that r is 1/2 and a is 64. So, bam. r equals 1/2 and a was 64. So now I got to find the 10th term. Whew. So I'm going to go plug that into my formula, and that gives me my 10th term is equal to 64 times 1/2 to the, what do I want, 10th term? So to the 10 minus 1 is 9, and that's going to give me, 64 times 1 over 5/12. Now, because this is a power of 2, and we got over a power of 1/2, you could be more clever and just notice that, well, whatever, let me just solve this one. So that gives you, multiply these out and you get 1/8. Alright, if you were more clever, you wouldn't have had to pause the video and get your calculator like I did, because you could recognize that 64 is a power of 2. So we have 64 is really 2 to the 6th, and times 1 over 2 to the 9th gives you oops, gives you 2 to the 6th over 2 to the 9th, which simplifies to 1 over 2 to the 3rd, which equals 1/8. So it's just an alternative, cleverer way of solving that. So I believe those are the trickier ones. There might be one more. Alright, here's our final one. Not super exciting. Not quite as cool as the other ones, but here we go. So let's say we want to find the sum of the 10th through 50th terms. So there's a couple ways to do this, but I think the easiest way is just to find the sum of the first 50 terms, and then find the sum of the first 10 terms, and then you can subtract those and see how much you're left with. Alright, so that's an odd sort of visual that should sort of convey that. Let's get this guy out of the way. Alright, so here you just simply do the same thing we've been doing for arithmetic sequences. You identify the first number, you identify the common difference. So what are we doing here? We're going up by 4s, so plus 4 plus 4. So common difference is 4. So you'd find the sum of the first 50, which is, oh, that's not even the right formula. The sum of the first 50 is going to be 50 over 2 times, come on, 2 times, my pen is not right for some reason, the first term plus 50 minus 1 times the common difference, which is 4. Get all that. So you get all that, and that equals 50, 50. Alright, so then you want to find the sum of the first 10 terms, and that's going to be this formula. And then that simplifies to 210. So the sum of the first 50 minus the sum of the first 10 is 50, 50 minus 210, and that gives you 48, 40 is the sum of the 10th through 50th term. The end.